Okay, so in this example, we're looking at a polynomial inequality, and these are going to be factorable, and so what we're going to want to do is factor that. And so let's see, this factors into, let's see, probably it looks like a -7 and a -4, right? And so what we're trying to do here is this product has to be greater than 0. So what I like to do is kind of make like a little number line right here, and the solutions to these right here are 7 and 4. Those are the solutions to the factors, right? And so I'm going to go ahead and put a 4 here and put a 7 here. And then what you want to do is you want to test points between and beyond those values that you find, the solutions to the factors. So 0 is always an easy one to test. So if we plug in 0, you're going to get, you're going to plug in 0. If x were to equal 0, you would get -7 times -4, which would be +28, which is greater than 0, right? 28 is greater than 0, so that comes back true. And so all these points will work to the left of 4. So 3, 2, 1, 0, negative, whatever you want, -10, -20, all those numbers will work. So that's part of my solution. Now, if I actually plug in 4, it will actually make it equal 0. It would actually make it equal 0, but I have to be greater than 0. So that means 4 is not included. So I'm going to use a parentheses, or you could do an open circle if you want to. But basically, I need to indicate that 4 is not included. Now we'll try a point between 4 and 7. I'll keep it simple. We'll try 5. So if I plug in a 5 for where I see x, I'm going to end up getting -2 times 1. And we're trying to figure out, is that greater than 0? And it's not. -2 is not greater than 0, so this one is false. So you don't want to shade anywhere between 4 and 7 because there's no solutions there. Then we'll go ahead and try beyond 7. We can try like 8. So if we plug in an 8, once again, I'm plugging it in for x right here and here. So I'm going to get a 1 times, what is that, 4, greater than 0. That looks good to me. Yeah, 4 is greater than 0. So that comes back true. So we'll go ahead and shade there. Okay. And then once again, if I plug in 7, it would actually cause it to be 0. But our condition is we have to be greater than 0. So got to put a parentheses right there. Now, the last part you have to do is you have to write this in interval notation. Okay, so you always want to go from left to right. So our left interval right here is going to be from -infinity to 4. And then we're going to use the union that you should see in your toolbar, the union symbol, and then union from 7 to infinity, and that's that second part right there. And that's the solution for that one. Okay, so I also received a couple graphing uh, quadratics. Okay, so what we're supposed to do here is the vertex. The vertex is going to be the highest or lowest point um, of a graph. Okay, and the way you can figure out the x values, it's equal to -b divided by 2a. And this is your A and your B, and this is C, but that's not going to be relevant here. So to figure out the x value of my vertex, I'm going to have -6. Okay, I got that's my B value right there. And then divided by 2 times A. Well, my A value is a 1, so 2 times 1 is 2. So I end up getting 6 over 2 because double negatives cancel out, reduces down to 3. So I have the x value. So the way that I can figure out the y value now is I actually just plug in 3. So I'm going to have 3 squared minus 6 times 3 plus 8. So I'm going to get 9 minus 18 plus 8. So negative 9 plus 8 is negative 1. So now I know the y value. So my vertex is going to be at 3, negative 1. So over 3, down 1. Now, I know it's going to open up. It's going to open up because the a value is positive. So when a is positive, it opens up. If a is negative, then it opens down. So I know my parabola is going to be opening up like this. So that means I'm going to have some x-intercepts. And so this is pretty easy to figure out because the factoring is pretty easy on this. So if we take this, that should factor into x minus 4, x minus 2. And so that means my solutions are at 4 and 2. So I have solutions of 4 and 2. And then the y-intercept's really easy to figure out because uh, the definition of a y-intercept is to let x equal 0. So if I do f of 0, I'm going to have 0 squared minus 6 times 0, and then I have that plus 8 on the end. That plus 8 is the only thing that's going to survive. Everything else just cancels out. So when I let x equal 0, my y value is 8 right up there. Okay? And then your axis of symmetry is right here. So if you really wanted to, you could count that's 3 spots away from the axis of symmetry. You can go 3 beyond. You could get another point there. When you're putting this in the computer, though, I think you only have to use 2 or maybe 3 points maximum um, in order for this to graph. All right, there you go. There might be some other questions about the range and stuff. I'm sure you can take care of that. Okay, this problem here is really no different. It is a little tricky, so I'm going to at least get you started on this one. What you're going to want to do is reset the order of this. So we're going to look at this as f of x equals, I'm going to put that negative x squared to the front, then plus 6x, and then minus 8. Okay, now to figure out the vertex, you are going to do the same thing. It's going to be negative b divided by 2a. And so in this case, it's going to be negative 6, right? The negative comes from our little formula here. And then 2 times negative 1. So I'll actually write that down. 2 times negative 1. Because my a value is an understood negative 1 in front. And so let's see. We're going to get negative 6 over negative 2, which becomes 3. That was the last one. It's a coincidence. Okay. So now if you want to figure out the y value of the vertex, you're going to have to evaluate this at f of 3. So we're going to have negative and then 3 squared plus 6 times 3 and then minus 8. So the negative stays there, so you got to square the 3, and so it actually is going to become negative 9 plus 18 minus 8. So let's see, we're going to get 9 minus 8, which is 1. Okay, so our vertex is at 3, 1. So over 3, up 1 right there. Now, you can see that the a value is negative this time, so the parabola is going to open downwards, right? Okay. Now, once again, it is factorable. And so what you would probably want to do on this one is factor out a negative 1 to get started. So that would turn this into x squared minus 6x plus 8 equals 0. So what I did was I'm trying to find the x-intercept. So you let y equal 0, which is f of x, right? So that's where the equals 0 comes from. And then what I did was I factored out a -1 out of all of these right here. So I have my negative in front, okay? Which really, to be honest, I could just drop it. It's not going to make a difference. But it's going to make the factoring easier that I did that. So this factors, I think this is the same as the last one. So it's going to be x minus 4 and x minus 2. So my solutions are the same. It's positive 4 and positive 2 from the previous example. That negative doesn't really play much of a role. It's just kind of sitting there. It's not going to make a difference because if I plug in 4, the whole thing goes to 0. Same thing if I plug in a 2. So the negative there, like I said, I could have dropped it. But anyways, technically what I had to do though was I factored it out. Okay, so got those right there. Then if I let x equal 0, I'd be left with just that -8. So there's my y-intercept. And then if you want to reflect it across, so this one's very similar to the last one, just that it's going to open down instead of up. But other than that, it's very similar. Okay, so these, I think I got about 2 or 3 examples very similar to this. Um, so to graph this is kind of a process. You have to start with the leading coefficient test. And so what you do is you look at the highest exponent with the highest power. I'm sorry, the variable with the highest power. Um, and so the way you determine this is when you graph this, what's going to happen is as x goes towards infinity, as x is increasing, this is your x-axis, this person's in the driver's seat because it has the highest power, so it's going to have the behavior of the graph in the long run, okay? So that's why we call it in behavior. So as the graph goes to the right, in the end, this guy is going to be in control because it has the highest power. And so like if I plug in 10, 20, 30, 40, whatever, raising it to the fourth power will be a big number. And then what's happening is it's getting multiplied by -1. So that tells me that my in behavior to my right is that it's going to fall. Okay. Because I plug in a big number like 30, 40, 50, whatever you want to plug in. Um, Raising it to the fourth power will make it really big, but then that negative value will make it turn negative. So you'll get like, -10,000 or whatever. And, this guy plays a role too, but that number will be much smaller in comparison to the leading coefficient. Okay. Now, on the other hand, if I plug in negative infinity, or like a big negative number, right? A big negative number. If you raise it to the power of 4, it's going to come back positive. So for example, let's say I plug in -10, right? Well, you raise it to the fourth power, so I still have that negative on the outside. -10 to the fourth power is going to become 10,000, positive 10,000, because even powers will come back positive, okay? But you have the negative on the outside, so that will make the end behavior fall also. So the graph falls to the left and it falls to the right. So this part's going to be C. Okay. So you'll, if you go back and watch some videos, we do have stuff about the leading coefficient test that you can kind of look at. Okay, the next part that you're supposed to do is factor it and then figure out the multiplicity. So what I'm going to do here, so I have -x to the fourth power plus 25x squared equals 0. What I'll do is I'll start by dividing everything by -1. It's just going to make my life a little bit easier. All I'm trying to do right now is figure out the x-intercepts. So let's see. So I divide everything by -1, so it changes the signs of everything, and 0 stays 0. Okay, and then what we'll do here is I'm going to go ahead and factor out the x squared. So I'm left with x squared minus 25 equals 0. So then I'm left with x plus 5, x minus 5 equals 0. So I have 3 x-intercepts on this one. I have 0, I have -5, and I have +5, okay? I got 0 from here, I got -5 here, and I got +5 here. Now, the multiplicity here on this one is 2. Whenever you have even multiplicity, that means it's going to touch and turn around, okay? So it's going to kind of be this shape when it hits the x-axis, okay? Now, if it's odd, if it's a 1, which these are, it's going to, oops, that would be confusing. Let me fix that. These right here will cross. They're going to cross. And it's actually going to look just like a line. It's just going to cross right through the x-axis, okay? So I'm going to go ahead and do a rough sketch up here. So let's see, I have one at 0, we're just going to turn around. I got one at positive and -5. Now look, I know my end behavior here is to the right. When I cross my last x-intercept, I'm going to go down. When I cross my last x-intercept to the left, it goes down. All that information was from the leading coefficient test. That's why I did that first part. Now, I know that through 5 and -5, I just cross. I just go right through it, and this is an estimate, and then I'm going to come back down. Now here at 0, I'm going to touch. I'm going to touch it. It's almost going to be a parabola shape, like this, and come back down, a bowl shape, we should say. And this can come back down like that. So it's kind of M-shaped, the whole graph right there. Okay? Um, so I know I got more examples similar to this, but I just want to kind of advise you that if you go look at if you go into your homework or review, um, there are a lot of tools there that can help you. So here, if you hit question help right here, they have view an example, which a lot of students really like. There's even a video here, so if you click on this, a video will pop up that you can watch of a similar example that's being worked. So I'm just showing this so that you don't always have to wait to get my response in case you're unaware of this, but just make sure you know you have these resources available. So that last example, there's about 2 or 3 others that you sent, but I'm going to go ahead and let you work on those, and you can let me know if you still need some additional help. The last one you sent me was the synthetic division, and so the rational list all the rational roots that are possible here. So what you have to do here is you take the ratio of all the factors of 9 and divide them by 1. So all your possible solutions are going to be positive and -1. 3, and 9. And so that's all the factors of 9. 1, 3, 9, positive or negative. And then divide them by positive, -1. That's not going to change anything. They're just going to stay positive, -1, 3, and 9. Okay, so what you're going to have to do here is just try something. So I'm going to start with, I know that 1 and -1 don't work. Typically, that's where you'd want to start, but I know that they don't work, and so I'm going to go ahead and start out trying with 3. So I'm going to put 3 here, drop the first number, so then you multiply, put that here, add, multiply, put that here, add, multiply. So that adds up to -3, bingo, I hit. So let's see, that's going to give us -9, so I have a remainder of 0. So one of my solutions I already know is 3. So I need to find one more though, because basically what happened was I whittled this down to x cubed plus 5x squared plus 5x minus 3. So what I did was I basically factored it because I know 3 is one of my solutions. So that means x minus 3 is one of my factors. So I basically took this and broke it down. I basically factored it by using synthetic division, really just kind of guessing and checking. So now I'm going to try -3. So let's see. I'm gonna use with what was left. So 1, 5, 5, -3. So I'm taking that from up here. Okay. And so let's see. So I drop down the 1. 1 times -3 is -3. -3 plus 5 is 2. 2 times -3 is -6. -6 plus -5 is -1. -1 times -3 is +3, which then gives me a 0. So bingo, I hit another one. So now I basically had factored this part down. So now I'm left with, let's see, this will leave me with x squared plus 2x minus 1. And then my two factors that I know that x plus 3 and x minus 3. And so I got that part from these solutions here because they gave me a remainder of 0. And then the quotient right here is what's left. And so you want to break this one down now. Now, we're done with using synthetic division. Because you could try 9 and -9, but they're not going to work. 1 and -1 don't work either. So you're going to have to do the quadratic formula for this last part. So you're going to have to do x equals -b plus or minus the square root of b squared minus 4ac all divided by 2a. So you're going to have to go ahead and do that to get your other two solutions. So you're going to have 4 altogether, 4 answers. 3, -3, and then you're going to have 2 answers that have square roots. Okay, and I'll let you finish that one.